Hello dear students, welcome to the lecture 5 of Object-Oriented Programming. I'm going to start our lecture with composing a new project. I have purchased a new microphone and it is finally arrived. Hopefully from now on my voice will be more clear and smooth. I have also purchased a new sound card to improve sound quality even further, but it hasn't arrived yet. So we are going to compose a VPF application, .NET Core. Let's select our repository. Okay, so here will be our folder. So we will start with object shallow cloning and deep cloning. In the previous lecture, we have seen the difference of how value types and reference types are kept in the memory, kept in the stack or a heap. So how we are cloning, making duplicate of objects make a difference. So there is two types of cloning. One is shallow and the other one is deep cloning. When we shallow clone, it is actually not cloning. Okay, so to do test of it, I am going to insert a list box. So this list box is added, however, it has no layout yet. And I'm going to set it as 500 and 500. Okay, so it is appeared. Let's make it a little bit smaller. Okay, so let's give a name to it. And name. Okay, so as we have talked, uh, class types, class type objects are reference types, and therefore, if you want to clone them, you have to properly do that. Okay, so let's compose a list, and I will make it have integer values. I'm going to make it like this, and let's uh, init that list with another void method. Okay. Or we don't even need this. So I'm going to init the list like this. We just need a small example phrase. So I'm going to add 10, 20, 30, 40, 50. Okay. Let's say with a shadow cloning click, I am copying my list into a new list equal to, okay, then, okay, this will be integer. Then I am going to okay, let's change the name of this into box results, clear, and I will change or yeah. So what do we expect at the moment? Why there are these what we are expecting to see on the screen? We will see the values of copied listbox results, right? Why these error happened? Do you know that? We have unintentionally made a great example. You see, it has thrown an error, and it said that the collection is modified. However, we are adding items to main list from second list. Why this error has happened? Let me show you again the error. Okay, it says that collection was modified. Enumeration operation may not execute. When you are enumerating a list, an array, if the objects of that list changes during the enumeration, it throws an error, which is collection was modified. So here we are enumerating the second list. However, we are not modifying we are not enumerating in main list, but we are adding values to the main list. So why this error is happening? We have copied main list to the second list like this way. However, this has only copied the reference, the pointer of main list, the address of main list. They are still referencing to the same values in the memory. Okay, we just copied their address. We didn't copy the values. Therefore, when I make changes in any of them, it will change the value of both lists because they are basically still referencing to the same data. There is a good example for this. If I can find it, I will show it to you. Okay, I'm checking some images to explain it better. Okay, so with shallow copy, you see they are still referencing to the same data. Okay, and with deep copy, they are having different address and different data. It is like a bucket. Let's say you have a bucket and you have either uh, and you have two uh, bucket arms to hold it. So you are basically holding the same bucket. Okay, let me find example of it. I'm trying to find a visual explanation so it can be better. Okay. So here, this is not a good example. Maybe, okay, here a better one. Better one, yes, the better one. You see, with shallow clone, they are referencing to the same data in the memory. With deep clone, they are referencing to the different data. So basically, this line is equal to this line. Okay. So these and these are equal because they are referencing to the same place. Okay. So this is shallow cloning example. And since this will give error, I am going to comment them. And let's say um, and list box results items add. Okay. So refresh list box will use the items in main list and add them to the list box. Okay, I'm going to add a refresh list box button. Which will just call the refresh method. Yes. And with shallow cloning, I will change the values of second list. Okay, so we can know what happens. So I'm going to change 30 to 400. Okay, but I am changing the second list. So let's see how it will affect the uh, values. Okay, refresh list box. This is the initial list that we had. You see here. And when I shallow clone and then hit refresh, you see now it is 400. However, I didn't modify this list, but since now they are equally uh, referencing to the same place, any changes on the second list will also change the first list. This applies to everything except string, because every time when a string is modified, a new string is generated. And okay, and this behavior, this or let's say reference type layer address name data. Okay. And there may be some better explanation on. Okay, let's read this.
In general, when we try to copy one object to another object, both the objects will share the same memory address. Normally, we use assignment operator, equals, to copy the reference, not the object except when there is value typed field. This operator will always copy the reference, not the actual object. For example, suppose G1 refers to memory address 5000, then G2 will also refer to 5000. So if one will change the value of data stored at address 5000, then both G1 and G2 will show the same data. Shallow copy, creating a new object and then copying the value type fields of the current object to the new object. But when the data is reference type, then the only reference is copied but not the referred object itself. Therefore the original and clone refer to the same object. The concept will more clear when you will see the code and the diagram of the shallow copy.
Okay, so this is the diagram example of shallow copy. You see they are referencing to the same data. This applies to all classes and class type objects. For example, let's say I have equal to 0 and I am composing my class data. $100, then I am composing another my test class, go to test, and then I am changing test to 200. However, for these cases, let's say because these are value types, not reference types. Okay, and I hover them, you see it is read-only struct. There is one exception for this, which is a string. So now even though string is class type, whenever you shallow copy it, it is deep copied. Okay. Uh, let's find that exception. Okay, strings are immutable. That is why. Okay, that is why they cannot change. The reason is this. Because okay, so SR2 is still referencing to the hello world in the memory. However, SR1 is now referencing hello home. So when we change SR2 to something new, it will also generate a new object in the memory, and it will be linked to them. So this is the reason. And okay, let's read this.
An immutable object is defined as an object that cannot be changed after it has been created. For many use cases, such as data transfer objects, immutability is a desirable feature. This article discusses why we might want to take advantage of immutability and how we can implement immutability in C#.
Okay, that is what is immutable. Okay, there is immutable stack. Okay, so let's take our notes. Okay, immutable, if I have written it correctly. Okay. So this is about shallow clone and deep clone. So we can run and see how they behave. I'm going to put a breakpoint here, run the application. Hit the shallow cloning example. So test is currently null. Now test has 0 as default. Now test value is 100. Now test2 is equal to test1. As you can see, the value is 100. Now the value is 200. And then when I check test, you see it is also 200. Normally, the integer is, as you know, value type. However, when it is inside a class object, it also starts behaving like reference type. We have seen that in the previous lecture, and then let's try with integers. IR1 is 100, IR2 is 100, IR1 is 200, and IR2 is still 100, because this is value type. Whenever you change value, it changes. And string1 is null, and now it is hello world. String2 is now hello world. Now they are referencing the same space in memory, but since they are immutable, when I change sr1 to hello home, now it composes a new string. This is also a let's say exhausting operation. We have seen that in the previous lectures as well. String operations are pretty CPU intensive because each time when you do concatenation or something, since they are immutable, it takes too much toll on the CPU. Okay, and now they are different values: hello home and hello world. Okay, I'm going to fix the word. What was it? Concan. Ah, oh, this one. Concatenate. This is a weird word. Okay, now if this way we are not able to, let's say, shallow clone it, how can we deep clone it? How are we going to compose a real copy of the uh, class objects? Okay, let's make example for that. In this case, so I am going to add another button to see real copy. I will call it as deep copy. Example. Okay, so let's compose a click event, enter, or double click. Okay, so I'm going to copy paste this. It is rather with simplistic objects or link queue supporting objects. It is easy. I am going to make second list as this way: to list. When I say to list, it composes a new list. Okay, because to list method returns a new list. You see, as it says it creates a list. So it is creating a new list, and when I make it like this, it will work. And let's try it. I'm going to change the object of the second list, and I'm going to add it to the main list. Okay, this will work. And okay, don't do this at the moment, and let's run it. Okay, refresh this up, deep copy, refresh this back. You see it is same, because now this is another list since I have used the toList method. This is a simple one. However, if let's say I have a custom class, okay, I'm going to expand my custom class here. Let's say name, the location. And let's assign them a default value. or let's say name is Furkan, location is Mersin, and the list and the collection has 3, 2, 1. So it has default values. I am going to compose uh, I'm going to compose a test class object. Test class, and I'm going to compose another test class. In test class, however, I will provide value as this time. How am I going to do that is, you see, when I hit spacebar, it shows me the public variables that I can set in the definition. So I'm going to say test val equal to 250 and collection equal to new list and 500 and 1000 and 10. Then location is Turkey and name is Toros University. So I want to copy the values of my test class to my default test class. How can I do that? How can I make a deep copy of my test2 into my default test class? There is no toString method here, or there is no deep copy or deep clone here. If I make it like this, how it copies, this is only shallow cloning. Okay, so whatever I change in any of them, it will be affecting both of them because it is only shallow cloning, and there is no, let's say, no method or extension to copy it, as you can see. So what can I do? I can code a custom extension to compose a full copy. Okay, so let me show you what I mean by that. To develop a method, I think we can make this. Deep copy. Okay, this will use actually the values of here. Public deep copy. Okay, and it will compose a new object. Temp object. Then temp object will get go to this test val, and we will copy the everything like this. You see, for each type inside this, I have to make a deep copy. Strings are immutable, integer is value type, and list needs a deep copy. So it will be like this, and this will be like this. Okay, so this will be a new copy. If I use the previous one, it will still be referencing to a collection. So I am making a list method call value type, value type, okay. And okay. And finally, we return the new object. So now I have coded a deep copy, and I can just use this for deep copy. Let me show you. Deep copy. So after this, when I change values in either of them, they will have different values. Let's test it. Okay, and to test it, I'm going to use a breakpoint, or let's make test first. I will just change a value of this collection, and and let's change this, and then change, and then I'm going to apply this to see how they behave. Okay, let's go with breakpoint and test it. A deep copy example, and currently the values of my default test class is 0, count is 3, 3 to 100, Mersin and Furkan. Test 2 has value as 250, collection is 500, 1010, location Turkey, and name is Toros University. When I copy reference of this to this, now they will be equally referencing to here. Okay, to memory location where this data is saved. And the data of default test class is now lost. It will be garbage collected by the garbage collector. So when I change location, I mean the collection of my default test class, it will change the both. Let's check it, 500, 1001, and let's check this one, 500, 1001. And when I remove it, modify it, it is 503 and 1. And let's check this one, 503 and 1. As you can see, it is all changing the same because we are only having a shallow copy. Then I am going to do a deep copy. Okay, now they are still having same values because we just did a deep copy, you see. Now when I change the collection number 2, okay, before I haven't changed it yet, it is 1. Oh, I need to provide some new values here so we can test it. Let's say 800, and let's say 5000. Okay, and let's say new and great. Okay, I'm coming here with a breakpoint. Okay, so now they are having the same data but different references. You will see that. So I have changed the collection index 2 to 800, and let's check the other object. You see now it is still 1 because now they are separate objects, and I have coded my own deep copy method. So this method is using this variable, which is the variables here inside that class. As you can see, So whatever the changes I make after deep copy, they will have, let's say, different values. Can I have deep copy automatically without coding a method like this? Okay, a method like this. Can I have deep copy? It is really hard, but I think it was possible. Okay, so as you can see, someone has written object extensions. It uses, I think, reflection. Okay, you see so many lines is. Okay, so which extends any class that has been marked as serializable. With this extension, if your object custom class is serializable, you can compose a deep clone. Okay, you can use any methods here. I think I will use this one because it starts with C#3. And to use this, we need to have a serializable class. I'm going to add a static class to have an extension. For extensions to work, you need a static class, and I am adding a new class and changing it like this. So I need to add related libraries. Okay, and let's compose a deep copy with this new extension. This time I will use extension method. Okay, deep clone. Okay, now let's check it out whether it is deep cloned or not. Okay, confirm. Okay, let's check it. So this is extension call and this was method call of the class. They are different. Probably the method call we have made would work faster. And let's check it. Okay, so it has given me an error that it is not marked as serializable. How it is written? Let's read it.
Serializable.
Okay, serializable. Hard to read.
Serializable.
Okay, so I'm going to mark it as uh, serializable. How am I going to do that? It is easy. So the class is here and I'm going to put just like this. So now it indicates that a class can be serializable. initialized, okay, and it says that this class cannot be inherited. Once your class becomes serialized, it cannot be inherited. So if you are going to use inheritance, you can't use this method. You will see inheritance in the future lectures. Okay, now let's try it again. Okay. Okay, now it works. And I have changed the list collection number 3. Okay, 800. Oh, I need to write some new values like this. Okay, so now it is 1800, and let's see the other. You see it is still 1, and now it is 15,000, and this is still 5,000. So you see it has worked perfectly fine. You can use either method, which whenever is more suitable for you. You can either code your own deep clone method, or you can use I think it was here binary formatter, which basically just I think copy of the memory. I'm not sure how this works, but uh, yeah, I think it just compose a copy of that memory. Okay, and assign it to a new reference. Okay, so these are the both ways of how to use deep clone and shadow clone. Objects, and let me check. Okay, serialization, deserialization. Okay, so I'm going to make this list box smaller because we don't need it at the moment. Actually, okay, I'm going to take a pause for a while. Okay, so let's start with a ref parameter usage effect, and what does it do? Okay, let's find some good explanation on the internet. Okay, there is a reasonably long article. I think. So, let's say I have defined an integer here. and I have a method call and I want to increase this value. How can I do that? If I make it like this, and I provide increment to my value, what happens? What would be the result of my value after this method? Let's try it. Okay, my value is still 100, and after 100 loop, it is still 100. Why? Because when you pass a value type into a method, its copy is passed, and whatever you do here is only remaining in here. Okay, it creates a copy of that value type inside increment. However, when you use a reference type object, it would be also effective inside this method call, and alternatively I can use this method. To do that, this time I will provide the reference and increment by ref. Okay, when I provide with ref keyboard here, it will be using the reference, and therefore the same value will be increased. Let's try this way. Okay, so my value IR my val is 100, IR my val ref example is 200, because since I have provided reference, it has increased this value. Okay, it didn't do a deep copy here. And let's extend it with string. And with this string, I will use this. T, and let's provide a string here. And here I will provide reference. Okay, it will be same here. Only we will provide a reference value. Okay, let's see the result. It will be the same because string is immutable. However, since I provide reference, it will be always assigning the new string to do its original reference. Let's see. So the first is still empty. However, when I check the reference, you see it contains all the additions to the original string value. And for reference types, this is important. What happens? I will provide a list here. Okay, list integer int and add. Okay. So will this work? Yes, of course. This will be still adding to this list because it is using by default reference. Since this is a reference type, let's check how it is looking after the method call. You see, all the values are there. However, since it was using IR value, it didn't make any difference of IR value. If I use it like here, and let's make 2 and just provide. I am not providing a reference this time. Okay, we will see the list 2 is having different values each time. Oh, I need to put a breakpoint. Okay, you see the second one is like this. However, there is something else I can do, and to show that I will make more lists, because this was already a list. Okay, so what I'm going to do is I will provide that as well. However, this time it will have reference, and okay, I will make it like this: new list by original list and add new random, or let's say this one. Okay, so here I have defined a new list, added range, range, and added some more value like this. Edit range, then oh, I need to make it like this. Okay. Oh, since it returns nothing, I have to make this. Let's make it like this. New list integers. Then add range, temporary, and then add like this. Oh, it requires additional. Okay, and I am going to apply the same here. This time it will be taking a reference example. I will be using it like this. Okay, so what will be the difference when I provide reference and non-reference list, and I use new keyword. So let's check the final result here. Okay, so let's check non-reference example. You see the non-reference example is 0. Why? Even though it is reference, when I define a new list inside the method call, it becomes a new object and loses its reference, and it has 0 elements, as you can see. However, when I use reference keyword here, it still keeps the original reference even though I use new list. Okay, so it contains the original values, and at the end contains for um, 40,000. Do you know why? Do you know why? Because every time it is becoming a 0 element, it is getting the values inside less lst temp and then getting this. Therefore, it has the default values and plus 40,000, which is added at the last method call. The previous method call addings are lost because every time it is becoming a 0. It is becoming an empty list. So reft word led us to define new instance of that object and still keep original reference. Okay. And were there any more feature of reference? I am going to check. Let's read this. Looks like a good explanation.
In .NET, when you pass any parameter to a method, a copy is created. In value types means that any modification you make to the value is at the method scope and is lost when you exit the method.
So what was the method scope? The scope is here. It starts with the curly bracket and ends with the curly bracket. So whatever you do is remaining here, not returned back to the method call here.
When passing a reference type, a copy is also made, but it is a copy of a reference, i.e. now you have two references in memory to the same object. So, if you use the reference to modify the object, it gets modified. But if you modify the reference itself, we must remember it is a copy, then any changes are also lost upon exiting the method.
Okay. So what does this mean? This means that, let me show you. Okay. It will take two lists. Okay, and let's compose two more. Oh, I can provide it here. This. Here. I'm going to compose a new list here. Equal to new list 12, 11, 22, 33. Then I will assign reference to here like this. So this will basically copy the reference of the new list to my previous lists, and let's see what happens. Okay, I'm going to put a breakpoint here as well. Okay, so currently first one is empty and the second one has 101 items. After this method call, first one is still empty, however second one becomes only 3 items because now it keeps the reference of this object and this object is now living in the memory. Okay, because the modification to the address of lst temp is lost because this is also copy of address. So when you modify the copy of address, it is lost. Okay. Okay.
As people have said before, an assignment is a modification of the reference, thus is lost.
Okay, so I think this explains quite well. So now you should get the idea of ref keyword. If you want to keep the original value, keep it as modified, you add ref word, even if you modify the reference itself, not the copy of the reference itself is modified. So this is why we use reference word. False, okay. And what else? Okay, what else we need? We have seen the file read, write, and exist operations, I think. I think I have also shown the public, private, protected. Let me check them quickly. Okay. Okay, internal, public, protected. Okay, we solved them. So I don't think we need anymore. Okay. Public, private, protected. Okay, okay. Yeah. Okay. In these, I think. So let's say I have to save my objects into a file and load from file. How can I do that? I can code a custom method to save state of my object into a text file and load it after that, or I can use serialization and deserialization with JSON to save it and read it. Okay, so did we show the inheritance here? Yes, I think we have seen it with simplicity. Okay. Okay. And so what I mean is, let's add a method to save and restore object. Okay. First, I am going to show inheritance and again, and then I will uh, show how to save object and reload it. Okay. Okay. So let's start with save object to a file method. Inheritance means that another class gets all the public or private or protected methods of inherited class. I think it is about getting private or not. I am not sure. And I am going to, we can't inherit this because it is serializable. Let's make another example. I have copied it. My test inheritance. Okay. And I'm going to compose another class. It will be like this. So new class name is test inherited, and it has, let's see which values, these dots. Okay, okay. Oh, I can't access like this. Okay, now I can access the variables. I can access protected value, name, location. Okay, I can't access the private value. However, I can access all other methods and variables of the inherited class. So this is inheritance. And let's see a definition of inheritance. Okay. In Turkish, they have uh, translated it as devralma. Okay. This is example. Okay. What is inheritance? Let's read it.
Inheritance is one of the fundamental attributes of object-oriented programming. It allows you to define a child class that reuses, inherits, extends, or modifies the behavior of a parent class. The class whose members are inherited is called the base class. The class that inherits the members of the base class is called the derived class.
Okay, let's write the definition. So, the child class is class inherited. The parent class is my test inheritance. I'm write it here. And there is also other definitions. Test inheritance. The is test. So these are the definitions of inheritance in this particular example.
C# and .NET support single inheritance only. That is, a class can only inherit from a single class. However, inheritance is transitive, which allows you to define an inheritance hierarchy for a set of types. In other words, type D can inherit from type C, which inherits from type B, which inherits from the base class type A. Because inheritance is transitive, the members of type A are available to type D.
Okay, let's make another inheritance. This will make it like this. Test val equal to. Okay, we continue. So let's make this method as set val. We'll make it 10,000 and collection as okay. Uh, like this. And this will also have some private value. And then I am going to compose another inherited class like this. And it will be like this. So in this case, the child class is child of inherited, parent class is test inherited, the base class is my class test inheritance, and the derived class here is child inheritance. Okay. So this time I can use, you see it says hides inherited member of the inherited class, so I'm going to set it as values, and this time I can access that values method as well. Okay, then I can assign more values as 100,000. Okay, so I am going to compose child of inherited class. As you can see, I can cascade inheritances. I think it is called as transitive inheritance. Let's continue reading.
Not all members of a base class are inherited by derived classes. The following members are not inherited.
Okay, so some of the things are not inherited, which are
Static constructors, which initialize the static data of a class. Instance constructors, which you call to create a new instance of the class. Each class must define its own constructors.
and finalizers.
Finalizers, which are called by the runtime's garbage collector to destroy instances of a class. While all other members of a base class are inherited by derived classes, whether they are visible or not depends on their accessibility. A member's accessibility affects its visibility for derived classes as follows.
Okay, so private.
Private members are visible only in derived classes that are nested in their base class. Otherwise, they are not visible in derived classes. In the following example, AB is a nested class that derives from A, and C derives from A. The private A value field is visible in AB. However, if you remove the comments from the cGetValue method and attempt to compile the example, it produces compiler error CS0122. A value is inaccessible due to its protection level.
Okay, so this is nested class, therefore it can access this value. You see, because it is in the same scope of class A. However, here it would cause an error because this is not anymore nested class but it is inherited class. This is nested inherited class and this is inherited class. Therefore, this can access to get value and the other one can't access get value. Okay, and other protection levels.
Protected members are visible only in derived classes. Internal members are visible only in derived classes that are located in the same assembly as the base class. They are not visible in derived classes located in a different assembly from the base class. Public members are visible in derived classes and are part of the derived class public interface. Public inherited members can be called just as if they are defined in the derived class. In the following example, Class A defines a method named Method1, and Class B inherits from Class A. The example then calls Method1 as if it were an instance method on B.
Okay, so you see method 1 is a method of class A and class B is inherited from class A. Therefore, class B can call method 1 as it is declared in class B.
Derived classes can also override inherited members by providing an alternate implementation. In order to be able to override a member, the member in the base class must be marked with the virtual keyword. By default, base class members are not marked as virtual and cannot be overridden. Attempting to override a non-virtual member, as the following example does, generates compiler error CS0506, less than member greater than cannot override inherited member less than member greater than because it is not marked virtual, abstract, or override.
Okay, so we have defined a method 1 inside class A, but it is not marked as virtual. And we have defined another method 1 inside class B, which inherits from class A. This causes error because the method 1 is not marked as virtual. Okay, so you can't compile this. However, if we define it as abstract, then we can overwrite it. Oh, abstract is different. Sorry about that.
In some cases, a derived class must override the base class implementation. Base class members marked with the abstract keyword require that derived classes override them. Attempting to compile the following example generates compiler error CS0534, less than class greater than does not implement inherited abstract member less than member greater than, because class B provides no implementation for A method 1.
Okay, this will also generate error because we have to override method 1 inside class B. Okay, and there is also implicit inheritance. Okay, so class implicitly inherits from object, struct implicitly inherits from value type object, enumeration implicitly inherits from enum value type object, and delegate implicitly inherits from this. Inheritance is a relationship. Let's read.
Inheritance and an is a relationship. Ordinarily, inheritance is used to express an is a relationship between a base class and one or more derived classes, where the derived classes are specialized versions of the base class. The derived class is a type of the base class. For example, the publication class represents a publication of any kind, and the book and magazine classes represent specific types of publications. A class or struct can implement one or more interfaces. While interface implementation is often presented as a workaround for single inheritance or as a way of using inheritance with structs, it is intended to express a different relationship, a can-do relationship between an interface and its implementing type than inheritance. An interface defines a subset of functionality, such as the ability to test for equality, to compare or sort objects, or to support culture-sensitive parsing and formatting, that the interface makes available to its implementing types.
Okay, so we don't need to get into the let's say interfaces at the moment, and what I am going to do is I will check that cannot be inherited things which were static constructors. Let's say if I put a static constructor here, but I cannot put a static constructor here because it is non-static class. However, let's try a static class. Okay. And this is going to have a static constructor as like this, which will take static constructor has to be parameterless. Will be like this. This will be also static. I am going to make it public. Then I'm going to compose another class that inherits from static base class, and we are getting an error. Static classes must derive from from object. Okay, so we cannot derive from static class to a static class, obviously. And another thing, instance constructors. Okay, so this throws error. So let's say I'm going to um, define a constructor. This is the constructor of the class, and I'm going to say get. I'm going to define a custom constructor like this, and let's say string. Okay, let's make it like this, and this will assign them to values like this. That. So let's start working with examples. I'm going to first. Okay, now it gives error. Okay. You see, now it is forcing me to create another constructor. How am I going to do that? Okay, this is interesting. This is a constructor. Okay. And let's take it. Oh, I see. Yes, now it makes sense. And from it will be base here. In message what is something. So it will be like this. Okay, so now it will be taking from a base constructor, and if I remove this, will it work? It doesn't work. So I have to add that as a base, and I think I can add more, like, and then I can use as this. Okay, that's okay. So I have to inherit the base, and then I can use it. Okay, this will also now require me to have bases of both, which means, okay, I have to write it like this, and this time it will require this as well. Okay, so let's now run them. I'm going to compose my first object, my base class equal to new. I can define it like this. Oh, I can't define it anymore, so I have to define another inheritance. I mean, I have to define another structure like this, which will do nothing. Okay. Okay, now it works. Okay, now this works, and I can also define another base class like this. This time I can provide uh, I can getting code from here. Test value and SR name. So test value will be this, and name will be. You see, it is now showing the variables. Custom name. So both works, and then I can compose a test inheritance class. Go to empty, or alternatively, oh, I can't use it anymore, so I have to define an empty one as well, I think. Like this. Okay, now it works, and alternatively like this, and do what else? Location. Okay, so how would you save this class into a file and then load it from file? You can compose a custom method to write into a file and compose a custom method to read from file. First, we will do that way, and then we will do the proper way, an advanced and more efficient way. Or let's say, okay, I think it should be All right. I'm going to take a pause. Okay. So let's put a breakpoint to see how they are looking when we are debugging. Okay, save object to a file. Okay, so the base class looking like this, default values, and the base class 2 is having the values I set, you see, like this. And first children class, you see it has all the values of base class plus private values of base class and inherited class. However, I am not able to modify private value inherited from the base class. I need a method inside base class to let's say access this private value. It is that is why it is green underlined. You see it says is assigned, but its value is never used. To be able to use this value, I need to have another method inside base class so that derived classes can access it. And let's define the final class. This is the child of a child. Child class. And version 2. This can also take. Okay, it says it doesn't have a default constructor, therefore I am going to define it. A default constructor with no extra values like this. And let's put another breakpoint. And child of a child will contain all the features and values of in parent classes. And let's define another method inside child of a child. And let's define okay. So you see with inheritance, we get a great usability. Let's say you have cars as a base model, then you are defining derived classes from car class, which are, let's say, trucks and um, let's say regular cars or tractors and such. You see child of a child now have all the values of previous parent classes, and also it has its own unique value here. So this is how inheritance works. It also inherits the methods and such. I think I will show the how to save the object into a file and then load from the object next week. Um, And we have composed a Discord channel for you to ask any questions you want. Link is posted on our LMS system, and moreover it is posted on the GitHub repository like this. You can join it and ask me any questions that you want. Please don't hesitate. Hopefully in the following weeks our videos will have better sound quality. It will be more understandable. Our subtitle generation project is continuing, so you can be also a volunteer to correct our following subtitles, for example, this lesson. Okay, hopefully see you next week. Always, you can ask me questions from my email and from our new channel, Discord channel. I have also posted a video about how to use Discord channel. Let me show you. Let's open our YouTube channel, and you see it is at the very end. I'm going to show you how to use our. Oh, it has generated some automatic subtitles for Turkish. Yeah, I will. For new Discord channel, I plan to fix this subtitle as well. However, you can watch it because it is in both English and Turkish. And okay, end of lecture. Hopefully see you next week.